Now let's take a look at the abstractions storage and runoff. So the two types of storages we're actually going to be talking about is depressional storage and detention storage. Now, depressional storage is, if you're looking at this parking lot up here, you can see a little bird baths or ponding areas. That type of storage isn't really enough to account for as an abstraction in our total calculations of runoff. Detention storage, it could be something like this down here in this yard. This type of detention storage, if it's large enough, we'll need to figure out the actual volume that this ponded area is holding. Now, sometimes to make our lives a little bit easier, we don't even bother to account for this. But if there's enough of these types of areas that are holding water, then for our calculations, we really need to take this into account. Now, go ahead and read through all of this information. I'm not going to cover it per se by going over the slides, but this has a lot of information that what we look at when we're talking about storage. Now, the other types of storage we're talking about is ponds, our stormwater management ponds or stormwater facilities, whatever you want to call them. We have two different types of ponds. We have retention ponds and detention ponds. Now, retention ponds basically say it's maintaining a pool of water throughout the year and holds the storm event. Detention means it's holding the water for a short amount of time and then releases it at a certain rate. Now, retention can be both wet or dry, and detention can be both wet or dry ponds. Now, when a dry pond says it's holding a pool of water, down here in this low-lying area, there's actually maybe, that's where the seasonal high water table is. That means it's like if you dig a hole around here in Osceola County, you're going to hit water within not groundwater, but you're going to start getting saturated groundwater about a foot deep. So if you're looking at this wet detention pond or retention pond over here, we have this control structure. Well, there's a grate on top of it, so as water rises up, it'll get inside this grate and then it'll flow out this direction toward us through a pipe underneath. On the opposite side of the one we can't see, there's usually some type of orifice or weir or some type of cutout notch that we're counting. You can see it over here a little bit more. There's a cutout on that dry pond over here, and this gravel is used for getting the water into the pond so it won't erode. Now, to summarize this, this is the abstractions that we have been talking about, or the hydrologic cycle that we've been talking about. Precipitation, evapotranspiration, evaporation, infiltration, percolation, interflow, subflow, streamflow. We didn't talk about these too much because that's more of a groundwater course than it is just your typical runoff. We do need to account for it if it's a big system. And then we have the surface runoff. So this picture here on the bottom gives a very good demonstration of all of these different cycles. So precipitation, infiltration, it goes down into the soil, it goes further down into the aquifer and turns into groundwater. Whatever doesn't go as an abstraction, like infiltration, inception, evapotranspiration, will actually go over surface flow, and that's what we're more worried about when we're designing. Over here, definitely take a look at the definitions that I've got. I've got precipitation, excess rainfall, or the total precipitation minus the sum of the infiltration and storage. Notice our biggest abstractions are the infiltration and storage. And then it goes on to explain what infiltration is. Reread these because you'll be expected to know these terms. Now, what we're going to be talking about next is this whole picture here. This here is a representation of what happens on the ground. Now, we have to mathematically model all of this, and we use what's called a hydrograph. And this picture here, this little curve-like, is our hydrograph, whereas this little rectangular or polygonal shape is a hyetograph, or an intensity rainfall not curve, but intensity rainfall distribution that goes with this hydrograph. So I'm going to go ahead and stop here and go back, and we'll talk about watershed delineation and watershed characteristics in our next videos.